Hello, in this video I will talk about how to use Tableau desktop for visualizing data. Tableau allows us to easily create a variety of charts, and it's very useful for creating interactive visualizations that allows the user to sort, filter, and otherwise explore data. So when you open Tableau desktop, you should see a screen similar to this one. This is the Tableau desktop home screen. The connect section on the left allows you to connect to many data file types, and the open section allows you to open sample data sets and worksheets, and these are the past projects. And the right side is the discover section. It provides information on ways to use Tableau. To open a file in Tableau, there are multiple ways. You can click on the file in the top ribbon and open. Or if you know the type of file you're going to open, you can find it from the connect. So for example, if I were to open a Microsoft Excel file, I can click Microsoft Excel. And then from the pop-up window, select the specific file I want to open. So this is a data file, contains data on the number of commercials run and the sales for an electronic store. Each worksheet contained within the Excel file will be listed in the Sheets area on the left of the dialog box. So Tableau can connect to multiple data sheets or data locations, but you must combine the data locations into a table using the new union function. In this Excel sheet, I only have one worksheet, so which is only one show up. Otherwise, you can connect to multiple ones using the common key, just kind of like ERD working for databases. The screen on the right shows a preview of the data file to which the Tableau is currently connected. You can see that the Tableau is connected to the data file using a live connection by default. This means that as the data file is updated, these updates will reflect in any visualization created using Tableau. Alternatively, Tableau can also use an extract connection, in which case all data from the file will be extracted, and any visualizations created in Tableau will not be updated as the data in the file is changed. The lower portion of the Tableau data source screen shows a preview of the data file to which the Tableau is connected. We see the columns from the file week, number of commercials, and sales. And we see the first 10 records for this data. We can change how many to less or more by changing the value in here. To update the visualization created in Tableau from a live connection, first save any change in the original data file, and then click Data on the top ribbon and select Refresh Data Source. Tableau saves files as Tableau workbooks with the file extension TWB, or as Tableau package workbook with the TWBX. So workbook of TWB extension contains a link to the data file being used, while package workbook with the TWBX extension also contains the data source files. So workbook of the TWB extension are useful because the visualizations can be updated when the source data file are updated. But if the data source is moved, the link will become broken and the visualization will not be able to produce. That's why I suggest if you work with others and share your file, it's better to use the package workbook, which is the TWBX file extension, because it contains the data file source to be used. So that way there's no confusion, there's no issues of the link being broken and the visualization cannot show. Next, let's use the file electronics _ T and to create a scatter chart in Tableau. So we want to first create the Sheet 1 tab at the bottom of Tableau data source screen. This will open a Tableau sheet as shown in here. So we want to drag the number of commercial from the tables area to the columns area to set the number of commercials as the horizontal axis value. And now we want to drag the sales from the measures area to the rows area to set the sales as the vertical axis value. So know that after this step, Tableau will display only a single circle in the chart as shown in here. This is because Tableau is currently plotting the sum of the number of commercials versus the sum of the sales. So next, we'll force Tableau to plot the values for the number of commercials and the sales by week. So we do this by indicating that the level of details that Tableau should plot is given by the value defined by week. So we want to drag the week from the tables area to the details box. This is the marks area. So you will find the details box over here. And that way we can set the level of details to weeks. So now we have more data points on the scatter chart. So now we want to add a trend line. So we right click the chart and select the trend lines and show trend lines. So we can see that there's a trend of going up. As the number of commercials increase, our sales increase, which is good news, right? That means our return on investment is good. Now I want to show you how to create a line chart in Tableau. So we have another Excel file. Let's create a Let's connect to the Excel file, which contains sales data in North and South regions. So when we first open up this data file, we can see that the current column titles are incorrect. So it shows that F1 as the title of column 1, F3 as column 3. The actual column titles are actually shown in the record row, month, north, and south. So the Tableau for this issue, Tableau provides a easy to use tool. It's called the data interpreter. So it can clean many common data errors like this one. So we just simply want to check the checkbox for use data interpreter in the sheets area. So this instantly change the column names to be month, north, and south. So we can then create a line chart in Tableau. So we want to click the sheet 1 at the bottom of the Tableau data source screen. So now we open a new Tableau sheet. So we want to drag the month from the tables area to the columns area to set month as the horizontal axis value. Now we want to drag the north from the tables area to the row area to set the sales amount in north region as the vertical axis value. So we also want to show the south region. So similarly, we drag the south onto the rows area to set sales amount in the south region as the vertical axis value. So we can also change the chart type in the drop-down menu from automatic to line. So instead of the default column charts, we see the line charts. And so we have two line charts, one for north, one for the south. But what if we want to put both north and south on the same axis, and so we can compare the two line charts easier? So we want to drag the sum south from the row area to the north vertical axis area and let go. And so this will put north and south on the same axis and for easy comparison. We can also change the value label on the vertical axis by right-click on that label and click Edit Axis. And now we can change the name from the default value to something like sales in 100s. So we can close that, and then so the y-axis label is updated. Next, I will show you how to create a bar chart in Tableau. We're going to use this data file called Accounts Managed. It contains data on the number of accounts managed by a set of account managers. After we connect this data file with Tableau, we're going to open a new Tableau sheet. And here I already renamed it to bar chart. Make sure the correct data file is highlighted if you have multiple ones had already opened. So first, what we're going to do is to drag the accounts managed from the tables area to the columns. This sets the horizontal axis value. Then we want to drag the manager to the rows. This sets the vertical axis value. So now we have a bar chart, but it is not sorted yet. So we can click the sort by descending, or we can sort by ascending. Now we want to add the number of the accounts as a label. So we drag the accounts managed to the label button under marks. So now we see that it's marked for the quantity of the accounts managed by each manager. Next, I will show you how to create a bubble chart in Tableau. So here we're going to use a data file called airport data. It contains data for 15 different airports, the data for each airport including the airport code, the average wait time at TSA, and the cheapest on-site parking cost, and the number of annual enplanements. That is in millions of passengers. So we first connect Tableau to the airport data, and then we're gonna create a new Tableau sheet. Here I already renamed it to bubble chart. You just need to double click and rename it, just like in Excel. So we first want to make sure that the data file is highlighted, and we want to drag the TSA wait time to the columns. So this sets as the horizontal axis value. Now we drag the cheapest on-site parking to the rows area. So we set the vertical axis value. Now we drag the airport code from the measure area to the detail button under the marks. So now we see multiple data points, each one representing one airport. Now we want to drag the annual enplanements from the table area to the size button. So now we see different sizes of the bubbles, and bigger ones representing busier airport with more passengers. Now we drag the airport code from the table area to the label button and the marks, so that we can label each bubble by the airport code. Now we have created an airport bubble chart. And you can see that it represents multiple variables, including labeling with the airport code and the size of the airport, how many passengers there in it, and also the TSA wait time versus the cheapest on-site parking. And you mouse over, you can see this 4 variables represented by the chart. Next, I'm going to show you how to create clustered and stacked column or bar charts in Tableau. We're going to use the same Excel file as we used in the line chart example. It contains north and south sales data by each month. So in the new Tableau sheet, we are first going to drag the month from the tables area into the columns to set the horizontal axis value. And you may have noticed right now, that we almost always use the text-based variable to set the horizontal value. And next we're going to drag the north from the tables area into rows. And so now we see a column chart for the north region sales data by each month. And we're going to do the same for the south region. So just like line charts, we now have two charts, one for each region. If we like to combine them both, we can drag, for example, the south into the north vertical axis. And now we want to show the different color for different region. So what we can do is that we can drag the measure names from the tables areas into the color button under marks. And now we see that blue stands for represents the north region, and the orange color represents the south region, and it's still by month. And so now if we want to change clustered column chart to a stacked column chart, then we can simply remove the measure names from the columns and force the Tableau to display both north and south region on the same column as shown here. So now we have a stacked column charts. We can drag the measure values to each label so we can see how many is there. I'm going to show you how to create a scatter chart matrix in Tableau. So we're going to use an Excel data file that contains data on the median monthly rent, the percentage of college graduates, the poverty rate, and the commute time for 55 subboroughs in New York City. So after we connect the data file to Tableau, we are opening a new Tableau sheet. So in here, we are going to drag multiple variables onto the column first. So we're going to highlight the commute time and use Shift key to highlight median month rent, percent college graduate, and poverty rate. And so we're going to drag all that into columns. So we're going to drag the same 4 variables into their rows as well. So we have multiple charts like this, and next we're going to drag the area subborough from the tables area to the detail button under the marks. So now we have individual points for each subborough. So now we can create the shape button in the marks area to select the filled circle. And then we want to make the size smaller, so we click on the size button to make it smaller so it shows the kind of pattern. So now we can see that for commute time over commute time variables to variable itself, we can see a positive 1 correlation because it's compared to itself, right? But we can also see some patterns such as take median monthly rent. The higher the rent, it look like associated with higher percentage college graduate, and negatively associated with the poverty rate, right? So the more poor and the lower the median monthly rent, the higher rent and associated with lower poverty rate. So this shows 2 opposite potential correlation. I'll show you how to create a tree map in Tableau. So we're using the file brand values, which contains data on industry segment and value in billion dollars for 10 of the largest brands in the US. So after we connect this data file with the Tableau, we can open a new Tableau sheet. Here we will create the tree map. First, we'll drag the value from the tables area to the size button in the marks. So this is where we use the relative value of the brand as a rectangle size measure in the tree map. Next, we'll drag the brand from the tables area to the label button under marks. So here we are labeling each rectangle with the name of the brand. Next, we'll drag the industry from the tables area to the colors button under marks. So now we can color the tree map by industry segment of each brand. So through these steps, we create a tree map showing here, and hovering the pointer over any rectangular shows the tooltip, which contains the brand name, industry segment, and brand value. Next, I will show how to create a Choropleth map in Tableau. So Tableau has extensive mapping functions for use with geospatial data, but here we will show only some of the simpler features. We use the data in a file called income state, and we want to create a simple Choropleth map. So the data in the file contains, as you see here, the median income for each of the 50 states in the US. We will use Tableau to create a Choropleth map that shades each state based on its median income value. So let's get started. We first open a new Tableau sheet. So based upon the state in the data, and Tableau automatically generate the latitude and longitude for that. So we drag the longitude into the columns and the latitude into the rows, and this will bring the map to our Tableau sheet. So whenever Tableau recognizes geospatial data, in this case it recognizes the states names in the data file, it generates latitude and longitude variables that can be used to create maps. Now we want to add more details such as state name, so we drag the state from the tables area to the details button under the marks. And so now we can see the state name shows up. And now we want to show different color for different income. So we drag the median income from the tables area to the colors button. So now we can see that the states that generate more higher median income are California, Alaska, New York, East Coast, etc. So if we hover over any of the states in the map in Tableau, you'll open a tooltip with the state name and median income value. We can also generate a map by dragging the states to rows and then use the show me to click on the map icon. So it shows the states in a US map, and also we can do the same by drag the median income into the color button. Next, I will show you how to create histograms and boxplots in Tableau. We can also use Tableau to create several visualizations useful for descriptive statistics, such as histograms and boxplots. So for the histogram example, we're going to use a file of age, death, and sex. So it contains the age of the death and the sex assigned at birth for 700 different individuals. After connecting Tableau with the data file, we open a new Tableau sheet. So on this sheet, we want to create a histogram of age and death and show the difference between the genders. So we're gonna drag the age at death from the tables area to the rows. And then we're gonna, from the show me, we're gonna choose the histogram. And so this will generate the default histogram. Now we want to drag the sex to the color button. So this gives us the different colors for sex, and female is blue, orange is male. So next, we want to change the bin size because there's some gap in here. And so we're going to right click on the under the tables, right click on the age at depth, and then click edit. And the size of the bins, we're gonna set it to 10 and click OK. So now we see that's consistent. So this way we create the histogram which uses the bins of size 10 years for the age, and this allows for compare between the distribution of the male and the female age of death in the data set. And from this histogram, we can see that many more females are dying at later age than the males. Now I will show how to create box plots in Tableau for multiple variables. We're going to use a file called home sale stacked. So this file contains the selling price for 50 different homes, as well as the size in square feet, the location, and the type of home, either detached or condo. So now let's create the box plots. In this box plot, we want to show the price by location and by type of the house. So first we will create a new Tableau sheet, and we're going to drag the selling price to the rows area. So this create a bar chart showing here. To create the box plot, we need to disaggregate the data. So we're going to click the in the Tableau ribbon, click the analysis and uncheck aggregate measures so that we can disaggregate the selling price values. So now we can use the Tableau's Show Me tool to create a box plot by clicking this box plot button. So now we want to create the box plot by location. So we're going to drag the location to the tables area, from the tables area to the columns area. So now we see that it's by different locations. We create different price box plots. Now we also want to use color to show the different home type. So we're going to drag the type from the tables area to the colors button under marks. So now we can see that the blue ones are the condo and the orange ones are the detached townhouse. So now we've created the completed multiple variable box plots. In this figure, we create a box plot for selling price of homes in each location, and the color of the individual data points in the box plot are differentiated by the home type, either condo or detached. So Tableau allows for showing many different dimensions on the box plots, as you see. Tableau can create many additional visualizations for data, including bullet graphs, violin plots, Gantt charts, and many others. Tableau makes it very easy to create data dashboards for that contains multiple charts. So to create a dashboard in Tableau, click on the dashboard in the top Tableau ribbon and select New Dashboard. You can see that all the sheets you previously created are in here. If you mouse over, you will see a thumbnail of it. And so you can drag each individual Tableau sheets from the sheets area into the dashboard, and you can include multiple of them. Like this. So Tableau also includes a presentation mode that provides better visualization of charts and dashboards created. So to access the presentation mode, click on the Windows on the top Tableau ribbon and select presentation mode. To exit it, you can just simply press the escape key.